Hi, this is Mrs. Doris. This is lesson 2-6 entitled Ratios, Rates, and Conversions. The objective is that students will find ratios and rates, and the second objective is that you will also convert units and rates. This is very important in real-world problems as you can compare rates in different units and also compare pricing. All right, vocabulary. We have several terms, so please pause this and make a note of your answers. Feel free to put them in your own words. A ratio is simply compares two numbers by division. All right, it always looks like a fraction. A rate is a ratio that compares quantities measured in different units. An example of this would be miles per gallon or miles per hour. All right, two different kinds of units, and it compares miles to either hours or gallons. A unit rate is a rate with a denominator of 1 unit. In other words, how much does 1 cost if you know how many 5 things cost? A conversion factor is a ratio of two equivalent measures in different units. It is always equal to 1. A conversion factor would be something like 1 foot is the same as 12 inches, or 5,280 feet over 1 mile, since those are equivalent measures. Unit analysis is something that we do that includes units in calculations that help us determine the units for the answers. All right, so problem 1, comparing unit rates. You are shopping for t-shirts. Which store offers the best deal? All right, store A has $25 for 2 shirts. So what we want to do is find out the cost for 1 shirt. 25 divided by 2 would be $12.50. All right, for 1 shirt. Okay, and notice if we wrote this as a unit rate and comparing it to the definition, they would put $12.50 per 1. All right, so that would be the unit rate written as a ratio. All right, store B. Store B has $42 for 4 shirts. 42 divided by 4 would be $10.50. All right, for 1 shirt. And store C is $30 for 3 shirts, which would be $10. So the best, you want to look for the lowest price, and that would be store C at $10. All right, going on to problem 2, converting units. What is 1,250 centimeters converted to meters? All right, so our secret here is we're going to use a conversion factor, and actually I'm going to go ahead and write the CM. This is using unit analysis by showing my units as I solve the problem and do the calculation. All right, so I have 1,250 centimeters, and I want to get rid of centimeters. I want to change my centimeters to meters. Now, when I want to do that, notice I put centimeters in the denominator, and that's because when I multiply, centimeters divided by centimeters will cancel out. So the question is, how many centimeters are in 1 meter? and that would be 100. So my problem becomes 1,250 times 1 over 100. And of course, this is 1,250 divided by 100, and that would be 12.5 meters. So 12.5 meters is equivalent to 1,250 centimeters. Doing another problem, we're going to convert units between systems. A building is 1,450 feet tall. So that's where I want to start. And notice I'm going to put the feet with it. And conversion factors, the implication there with a factor is we are always going to multiply by an equivalent ratio. How many meters tall is the building? All right, so again, I want to change feet, so I'm going to put feet in the denominator to meters. So meters will go in the numerator. And this way my feet will cancel out and leave me with meters. All right, so we are given that 1 meter is equivalent to 3.28 feet. All right, multiplying then, 1,450 times the 1 would give me 1,450, all divided by my 3.28 in the denominator. And when you divide, you get 442.07, which is about 442 meters. All right, so the building that's 1,450 feet tall is about 442 meters tall. All right, another problem of this sort. Monetary exchange rates change from day to day. On a particular day, the exchange rate for dollars to euros was about $1 is equal to 63 hundredths of a euro. About how many euros could you get for $325 on that day? All right, so we are starting with $325. We're going to use a conversion factor, and notice a conversion factor is always equal to 1. And this is the conversion factor that we have. Now, since I'm changing my dollars, I'm going to put my $1 in the denominator and my 63 hundredths euro in the numerator. And this causes my dollars to cancel out. So my problem basically becomes 325 times 63 hundredths. And my unit then will be in euros. All right, so multiplying these together, we get 204.75, which is approximately 205 euros. Problem 4. An athlete ran a sprint of 100 feet in 3.1 seconds. So I'm going to write my ratio 100 feet. Notice that I am labeling it in 3.1 seconds. Okay, at what speed was the athlete running in miles per hour? And we're going to round to the nearest mile per hour. All right, well, I want to change. This is going to require several conversion factors. First of all, since I have feet in the numerator, I've got to put feet in the denominator. And I want to go to miles, so I happen to know that there are 5,280 feet in 1 mile. All right, so already I have canceled out my feet, and if I solved this problem, then I would have miles per second. All right, so we want miles per hour. Well, I have my miles on top, so that's good, and I'll circle it because we're done with it. But we've got to get rid of our seconds. So I do happen to know that there are 60 seconds in 1 minute. All right, so my seconds will cancel out. All right, and this would give me miles per minute. But I want to go to hours. So since minutes is in the denominator, my minutes have to go in the numerator so that they will cancel out. And there's 60 minutes in 1 hour. All right, so my minutes now will cancel out. So notice the only units that I have left is miles on top, hours on the bottom. So when I solve this problem, that will be the units for my answer. So let's multiply. We have 100, okay, times the 1, times the 60, times the 60. And of course I can leave the 1 out. We know that won't change the value. On the bottom, I have 3.1 times 5,280 times 1 times 1. So again, that won't change my value. Multiplying this out, on top I get 360,000. On the bottom, I get 16,368. All right, and when I divide, I'm getting 21.99 something, which is to the nearest mile per hour would be 22 miles per hour. All right, so in this problem, please note that 1 mile over 5,280 feet, that's equal to 1. That's the same distance, just in different units. 60 seconds in 1 minute is equal to 1 because it's the same amount of time. And 60 minutes in 1 hour is also equal to 1. So I'm not changing the value of my original problem. I'm simply converting it so that I have my feet cancel out, my seconds cancel out, my minutes cancel out, and I end up with miles per hour. All right. All you have to do is take your notes and post your question or just a quick little summary of the lesson on Canvas. And I will see you on Monday, and we will be working these problems. Thank you.